Hello and welcome to this wonderful presentation by Dr. Hala Nelson. Dr. Hala Nelson is a professor of mathematics at James Madison University. She is also the author of Essential Maths for AI. Is it maths or
Math.
math? Math. Okay.
Singular.
Depends if you're British or American, right?
Exactly.
So today you're going to give us an exemplary overview about navigating the AI frontiers. And I really appreciate your pragmatic, but also pure perspective from mathematics on
Yes,
how to develop a unified view of the world.
correct.
So with that, it's the mic is yours.
Thank you. So we're gonna thank you for Joaquin for putting together such a nice conference. I tagged the talks and I will be going back and rewatching them. So thank you for finding these awesome speakers. Um, so my the title of my talk is that to navigate the AI frontiers in an organization or in your own applications or in your life, it really depends on exactly what it is that you're doing and what your perspective is. Um, so, as Joaquin said, I'm a math professor. I come at this from a mathematical perspective, but I also learn the other infrastructure that I need to make AI um, a- applicable and deployable in an organization. So, I'll show you exactly what I mean by that. Um, so I managed to like think about AI and my work in AI, and I managed to divide my work into four layers, and each of these layers has needs different skill sets in terms of how much AI or math or coding or data engineering that you need to know. Different strategies on how you're gonna go about implementing AI, different proficiency levels, domain knowledge, different technological tools. Sometimes you don't need technology at all. Sometimes you need all kinds of technology and how you gonna integrate it. And of course, the most important is funding levels and of course time. And so time and people investments in the end is money, time, and people are in the end what makes things happen and move toward AI powered organization or not. Um, so here are my four levels of working in AI. So if you look at this triangle from the bottom up, you notice that the need drives the use of AI. What stuff you want to automate, what stuff you want to use AI to get insights for is what's driving. But if you look at this triangle from the top down, it's strategy at the top level pushes down the adoption of AI. So I'm going to go through these levels today one by one. Right now, I'll just say them fast. At the bottom, there's the real life projects and immediate projects that need immediate application of AI. And then the next level are the foundational models of AI, machine learning algorithms, knowledge graphs, basically what powers these technologies on the theoretical level, wanting to understand them and all of that. And then on top of that, there's the interface of AI and data infrastructures. Basically, if you want your projects to come to become automated or at scale or to deploy themselves, then you do need to have some understanding of the data infrastructure and the pipelines and the organization and the data governance in your organization. Um, and the IT assets. And then at the very top, you have the AI and data strategy at the institutional level. So almost every company I talk to, every organization, every industry, every department, all of them want to devise an AI and data strategy because they see the potential. So they are kind of all headed in that direction. Whether they accomplish it or not is a different question, whether they just do a strategy and then not invest in people and infrastructure, etc. It's unclear, but that's basically the four levels that these are the four fields or layers that I find myself always in. Now, ideally, the bottom up and the top down have to meet, and when they're aligned, when the need, and when the strategy aligns with the needs and the vision and the mission, all of that, that's actually an ideal situation. And again, it depends on the culture of the institution or the organization on whether you're gonna have this optimal alignment from everywhere with and match it with resources, with people, with time, etc. um, the other thing is that these are not fully separate layers. They feed each other and they inform each other very much, but you can definitely find yourself in one or more of these layers. So I'm going to start at the bottom level, and that's the real life projects with immediate business or mission value. So, in my opinion, projects and time and people investment, they shouldn't go to project wasteland. So many projects get started, never see the light of the day. So much, there is a big wasteland in terms of technical stuff or even initiatives. A lot of them just never see the light of the day. So if you add how much resources are wasted on such projects is really bad. So usually in our consulting work, I noticed some commonalities between institutions, organizations. They basically have commonalities, even though they're trying to solve different problems. But what I see is blocking them from implementing, from getting to where they want are similar things. Um, so basically, what drives me usually is seeing a project through. So we are given, say, a consulting project with any sort of organization. Recently, we've worked with Harrisonburg City's fire department. We worked with the transportation department, the bus system. We worked with U.S. Air Force, U.S. Navy, U.S. Department of State, Diplomatic Security Services, and from all of these, we got very interesting projects. A lot of them would say they all wanted AI, but some of them didn't really need AI skills. Some of them did. Some of them needed integration of engineering, strategy, policy, etc. Um, we're faced with a project, and I've noticed like a method to get it from a question to exactly assessing the landscape of the organization and then addressing the needs and then in an implementable way. And for me, like the most important thing is being implementable. You can suggest all kinds of solutions, but if you're not at the same time talking to everybody on the ground all the way up to the sea level, people who are getting their hands dirty and doing the actual work, like the Marines, for example, the regional security officer, whoever is on the ground working with the technologies or implementing the technology themselves, all the way up to the sea level, or who actually see the big picture, know their resources, know what's possible, what's not. So when we talk to people at all levels, and all of you are addressing one project or seeing their perspectives on one project, then you have the capability to come up with a solution that is definitely implementable and sees the light of the day. Um, um, so I'm always all about getting regular feedback on the solution as you're developing it from people at all levels. And then also you can expect a lot of resistance and red tapes. People usually are used to the technologies that they use, and they're used to doing things one way. So if you suddenly come and tell them you need to record this data, you need before you close a work order, you need this data to enter it, and you need some standards and etc. So there is some resistance. Sometimes you're not given the data at all, and you're still expected to find solutions. For example, you're like the other day I was talking to someone in Paris who's working a great project. matching column data, the data, the metadata for columns and databases in a company to the business glossary using language models to do that. So, but they had great ideas, great models, but they didn't have any labeled data. Sometimes you can get the data for security reasons that you are not authorized to get this data, but you're still asked to get to come up with something. So you always have to know why you're not getting data, and or if you can come up with the data yourself, or if you can fill in the distributions of what you think the data is going to be, or you just deliver a design and these people with the data can implement the design or not. um, and also do not like just have keep an open mind in terms of what technologies to use, what technologies people are comfortable with, etc. So I've noticed that when we do things this way, we always get to implementable solutions. And sometimes you don't really need technology at all. What you need is a change in the language of the policy handbook. So again, even though you come as a person who's supposed to be an AI consultant, and then when you assess the whole landscape, the solution doesn't need AI. It just needs changing of some policies in the language. So again, keep an open mind. Just the fact that you're an engineer or doesn't mean you have to engineer a solution right now, as much as we like to build things. So that was my experience on the bottom level, basically the actual work that we've been asked to do. Um, of course, some bragging rights here. Here's my students. Actually, this us, but this is my students presenting to the Diplomatic Security Services headquarters. The Assistant Secretary of State was there. Here they're presenting at the Pentagon some about creating sandbox for blockchain technologies to put into the logistics operations of the Air Force at the time. Here's the fire chief in Harrisonburg. Um, um, with my students, they we found we kind of located we and we studied their data, joined it with all kinds of information, the call data from 5 years to and the question was, where should the new fire station be built in order to maximize coverage for the whole city and basically make it safer and attract more businesses. So it's always good to know exactly what the business value is, what the mission is, and so there's some bragging rights here. I'm talking soon at the ATARC GTEC conference. This is a nice conference where all the tech techie people in the federal government, all kinds of departments will be there. So you would learn here on how the government is thinking about bringing in AI and generative AI into all layers of its operations, whether that's a good idea or not. This is going to be confirmed soon at speaking at the Science Summit at the UN General Assembly in New York in September. Anyway, so basically at that level, you can engage, you can give talks, you can give training courses to your employees. You can collaborate, pick up everybody's way. We all know one piece of the story. Um, and then um, and then it's always good to know at the big level who's developing AI and where is the rest of the world. Who are the leaders in AI development? At the big level, it's the US, Europe, China, but the rest of the world also is trying to harness these technologies, and so that's where your chances are, and where the opportunities are. And what I've been finding a very good opportunity where to start is building digital twins for your organization, how it operates from a high level. Building digital twins is a very active and nice field now, so there's opportunities there. All right. So the next level, on top of the bottom level, there is the foundational model. If you're researching AI, trying to make these models more expressive, less hallucinatory, I don't know, more faithful to reality. Then you need to understand the actual algorithms and what they do and what their limitations are. And I'm interested in these models both as standalone models, like someone gives me a data set and I will someone give me a data set and I will do stuff with it. Like I will find insights, make decisions, say the data is whatever, or or how actually you're gonna integrate these models into a production pipeline. Say you have you're like I don't know, the commander system in a business, uh, or just like how these things integrate. How's my phone when I open it? It's classifying all my images. These are snow images. These are others. This is a simple application. So I'm interested in both, and for that we need to understand the models that go into these systems. One way I found, and I actually did in my first book, Essential Math for AI, is I unified these models into one mathematical structure. So when you understand that all of these models that you see out in AI world are not really 100 million models, and every day there's something new. When you understand the foundation and you're able uh, to move from one model to the other without thinking you have to learn a whole new 100 books of mathematics. You don't have to do that. So I did determine that all AI models out there are basically belong into two schools of thought only. One school of thought is the probabilistic school of thought, where you're learning the probability distribution of the data that you care for. For example, the probability distribution of, say, the English language and how people use it, or deterministic models, where you're actually learning functions. You know exactly you put an input, your model takes an input. Because the model is deterministic, it's going to create the same output for the same input every single time. So these are two so the generative AI falls mostly in the probabilistic realm, but right now they're building knowledge graphs on top of it in order to kind of make it more so I mean, if you're only sampling probability distribution every time you put a query in, you're gonna get some bad samples, and that's a hallucination. So basically, they're putting knowledge graphs on top of these, and actually before they're doing retrieval augmented generation. So they're putting something deterministic before the model and after the model, and then that's kind of making the results better. But anyway, mathematically, not very difficult things are happening. They're very in each of these schools of thought in any model. You're either learning a joint probability distribution of your data, or you're creating a function, a deterministic function that tells you how the features of the data interact in order to give your model's prediction or classification or whatever. Um, so I do also have a pipeline for the math that goes into these models. So you have in the input is any type of data. So what happened is in the past all the data was structured, all the digital data at least was structured. But now we want to create insights of all kinds of data. We want to integrate data, whether it's images and text and audio and tables. So the idea, but mathematically for me, I just see it as input data, just any type of data. And then my AI models are transforming this data into numbers, vectors of numbers most of the time, or matrices of numbers, arrays. And then these are super high dimensional. So there's some math that's required to actually reduce the dimension while keeping the essential information. And that's where all your models come in. So basically, your input data becomes vectors of numbers, and these are retaining the most essential information. And then you put those vectors in some function that results in a decision, a prediction, etc. And then, of course, you have to test whether you're getting the right thing. You have to iterate on the process. You have to always say where you're getting the data. Um, a lot of the models and people confuse linear models with nonlinear models. So I stress very much whether my model is linear or not linear. Linear means flat, very easy to interpret, you know exactly the contribution of each data feature to your output. But the nonlinear is more complex but more faithful to reality. Um, Sometimes more faithful to reality, so because sometimes reality is actually linear depending on what you're doing. But this is basically gives you this differences between if the decision boundary is flat or curved, um, again depending on what your use case is. So this mapping from input to output, from basically from input to vectors of numbers, and all of this from here to here, that process can use some linear functions or nonlinear functions, and I'll talk more a bit in a bit. All right, so this is my work in foundation model. Always trying to understand the models, their limitations, and combine them together to see how we can improve. And then the next layer would be automation at scale. So automation, I mean, it's one thing about why did language models blow up and become very famous in the past 2 years? Because you're calculating with language instead of spending like 5 hours creating a paragraph. Say you're a writer, I mean, you can spit it out in like 2 seconds, and there's and it's nice to have that process automated, like integrated into your workflow. um, but then for you to like harness the power of AI into your workflow, into like the pipelines of an organization, whatever, you have to have understanding of the interface between AI and its potential and the data infrastructures. So you have to learn about the data infrastructures at an organization. You have to see how are the pipelines and where can we automate, and whether that automated process is going to cost us a lot, or are we going to remove the whole infrastructure, build it again, which is not good. So basically, you want to understand this interface at all levels of the supply and value chain in your organization. Now, this is the thing that I was not comfortable with, because I come from this side of my background is in mathematical modeling, physical phenomena, statistics analysis. So my background is pretty theoretical and computational, which means I've never really dealt with data pipelines. I've always received the data set once it's clean, and I do stuff with it. And sometimes I don't even receive a data set, I simulate one. So I was like in a happy world here where none of the difficult parts, in my opinion, difficult, in your opinion, probably maybe you're in one of these, but not the other. You think the others are difficult. In my opinion, AI stands on these four pillars. And for you to have a good AI strategy, data strategy, you have to have a good understanding of how all of these play a role. Um, I had to learn all of this. I had to learn. I mean, I'm not an expert at this. No one is, but at least I have to have a good understanding of how these interoperate. And then, so there's a hardware, the engineering. NVIDIA, for example, is doing amazing things now. Robotics, drones, autonomous vehicles, all of this it lies in the hardware realm. There's the data engineering and system design, and there's all, of course, the software engineering, programming, implementation. So if you want AI, it really stands on all of these. There is no choice, right? If you're only doing one, you're not kind of not becoming a fully AI powered institution. Um, um, so one mistake that I find people fall into is they try to reinvent the wheel. They come from one of these pillars and they started kind of doing analysis or themselves, or doing hardware engineering, or commenting on it themselves. It's actually, in my opinion, a team has to include experts from all of these, because otherwise you run the risk of reinventing the wheel, because there are some hard earned lessons that these people learned that these people do not know. And so it's always good to try to have these people on your team and not reinvent the wheel. And I mean, the problems that you're encountering implementing something, someone must have encountered it at some point, because that's what they do, but and they figured out solutions for it. So it's always good to have you talk to all of these. I noticed that to make things easier, to for me, the way I understood data engineering finally is to actually visualize it this way: is like you have, it's always like a pipeline. You have some input, for example. In data engineering, you have a whole mess of data sources as an input of all types of, and their metadata and all kinds of stuff. And then it goes through the data engineering pipelines. And then what you get on the other end is nice data, pretty data like CSV files or whatever, Excel, whatever data you get at the other end, supposedly ready for machine learning algorithms, for AI models, for dashboards, for business intelligence. So if you think of things as input, stuff that happens to it, output, if you actually are able to identify what's the input, what's happening in the middle, and what's the output that you care for, you kind of, it helps you like understand all kinds of things. And these are other examples on machine learning models. What's the input? For example, I do a post on Facebook, then it goes through a machine learning model and tells me if my post is harmful, tells them, not me, if the post is harmful or not, and that triggers another set of actions based on that decision. Um, for example, if you have a query to a large language model, you have a whole lot of computation, you have embeddings, you have transformers, you have knowledge graphs on top, you have retrieval on bottom, and then you get a response. So if it's good to see it this way, it kind of helps your brain. Okay, so that is like the middle ground. And if you notice, this is where a lot of people in our industry are in. They're always at the interface between data and infrastructures. Now, at the very top level, there is a AI and data strategy. At this could be at an institutional level, could be at the state level. Say the governor pushes down a directive on AI and data strategy, or the EU, the European Union Act for AI and data. So basically, that's a very, very interesting realm because it helps you see things from above, and also talk about the organization as a whole. For example, what you see here is my university's JMU, James Madison University, is where I teach. This is the organizational chart. It's nice to have like a digital twin here and see what the IT assets in each division, what kind of data they consume, what kind of data they produce, how do they want to use AI, and all of this. So and then devise a strategy, and you want AI. Well, I'm sure every people in each division don't think of the AI that way they want as the same AI as people other division, right? So and also whatever model you come up with or strategy, it has to be flexible and not rigid. For example, recently we have this whole part of we have a whole division here, a subdivision. This research and development became its own division in the university. So instead of reporting to the provost, this whole division is going to report to the president. So whatever data model you're doing here has to be flexible enough and not rigid. Um, and there's a lot of data engineering you learn. There's you kind of it's a nice application, but it does bring me back full circle to math and models. So thinking of this helps me want to understand more exactly what's happening in the infrastructure, how who wants what, and one big thing about the data strategy, the top level, is that you always are thinking about regulation and compliance with government directives, acts, uh, explainability, etc. So when you're devising a strategy, you have to be compliant, and you have to you might have a chance to even shape the policy and kind of give feedback on whether these directives are realistic or not. So what I noticed as common between the US and Europe, I noticed that everybody is, if you want to deploy AI systems and in production and have them make decisions, then your AI has to be explainable. So explainable meaning, and I'll go over what mean by explainable AI. If basically you're processing, computing, analyzing, and making decisions, it's very important. You're making decisions with high dimensional data using an algorithm or an AI, then the AI has to be able to explain how it arrived at this decision that affects real lives and real people. So being here and thinking about AI strategy as at an institutional level brings me to compliance and brings me to explainable AI. Explainable AI brings me back full circle to mathematics, because you have to know what explainable AI is, and how to make these AI systems explain their thought process. Um, so, so basically, what we're doing in AI is always representing high dimensional data. It could be any form of data, images, video, tables, time series, log files, audio, tables, language. It can be any form of data. You're basically moving it into vectors of numbers in a linear, which is or nonlinear way. So the function that's moving you from a data source and form into a vector of numbers that you can do calculations with the algorithm is either linear or nonlinear. Now, linear is easy to explain. You know exactly how each feature of your input contributed to your output just because it's coefficient of the feature itself in the linear function, or nonlinear. And here you need more math. And this is very interesting because a lot of people just don't want to do the math and they still want to use the algorithms, and it is where I come in and I'm like, no, we're gonna explain it. So this is an example. For example, the convolutional neural networks that are mostly used for computer vision. They basically any neural network for any purpose is a nonlinear function. So it moves your input from any input, it moves it into an output which is a vector of numbers, and then this function that's moving you from here to here, which is the architecture of this neural network itself, is a nonlinear function. um, for example, here, this is a linear example. I'm not going to explain how. If you read my book, you would know that this is linear. This is an image, an input image. You do a convolution with a pre-designed filter, and then you pick up in the output, you pick up on the vertical. You see the filter is vertical, you pick up on the vertical. These are called Gabor filters. Anyway, so my point is the input can be an image, whether this one or this one. The output will be a vector of numbers. Here, if you flatten this from a matrix to a vector, you get a vector. But then the function that moves you from here to here or from here to here can be linear or nonlinear. The linear is easier to explain in terms of AI, and it does give you good results. It's not Nobody said that we always have to use neural networks, but neural networks are super expressive. So we do use them because they work, but then we have to work then what does it mean to be explainable. So I actually do the essential components of explainable AI. Essential components of explainable AI, in my opinion, are we and the AI itself as to understand the models, the data that went into the models, and the deployment use cases and the limitations. We have to understand that. We cannot just like grab an algorithm and throw data in it and get output and start using it. We have to understand what's this algorithm limitations and whether it's okay to use it in the setting or not. We want to understand the exact contribution of a data point attribute to the embedding dimension, to that vector. How does a feature of the data contributing to the output vector, that, and based on that output vectors you're getting decisions. And then you want to understand the pipeline from data to embedding to decision. um, and you have to quantify and report the uncertainty in the model's prediction. You're getting numbers. In the end, you're inputting numbers and outputting numbers. And then based on these numbers, you're making decisions. So, of course, you have to quantify and report uncertainty. But then, how do you do that for highly nonlinear models? And that's where we have to come in as mathematicians and work these computations out. And also, you have to quantify causality. Everybody says correlation is not causation, but we have to quantify causation. The AI has to be able to reason on why it made this decision and not that decision. Now, relying on observing data is not enough. So, this is from this is from Judea Pearls, the Book of Why. He does a lot of causality quantification, and he uses graph networks to do that. But the whole idea um, is that you're basically calculating what's the probability of having this output given by observing this input, the features of this input, and then you can intervene. What's the probability of having this output given this intervention in the input, and what's the probability of having this output had I not intervened in that way, right? So that there is some, the difference there is you're actually quantifying causality and having being able to make statements about it. Um, so so decision makers, they always wanna say, well, if I change the color in the bus route system, is that gonna increase ridership? You always wanna like see it changing a variable, changing a input feature. How does it affect the output? Whatever model you're using in between, you need to be able to make that calculation. If you change, it's basically the first derivative of the output function with respect to the input. But how do you measure that, and how and put it in production and always report it? So we have to make these calculations. Um, all right. I do think we have an opportunity to shape this field. It's amazing the interest in AI, and because there is potential, it's not hype, but we have to be very thoughtful on how we're doing things and how we're integrating things, and are we reporting the limitations of these things, and are we calculating the risk, etc. And all of that needs to be quantified. So we as mathematicians and you as development engineers, heads of heads of companies, whatever, you have an opportunity to shape this field. And we have to know invest time and money smartly. We have to like step back and see whether doing things in such a different way is worth doing to start with. Exactly, what's the cost benefit analysis? um, in my opinion, this is the right foundation for AI and data and information. At the bottom, there's the hardware, there's security, there's the data sitting at the heart of it all, and system design. There's the communication information, there's the modeling, and there's all the applications here. And of course, at the top, there's the AI, the enterprise strategy. And the gaming industry, I mean, NVIDIA, if you think about it, started for gaming, right? So the contribution of the gaming industry is amazing. So I always acknowledge that. And always you want to think, who are you in this world of AI and data? Are you the engineer? Are you the plane's engine? Are you the pilot? Are you a passenger? Like, exactly, like identify your role in all of these layers, and that usually helps you focus and look in the right places for the right things. All right, so we keep learning. These are what I do so far, and follow me. And thank you.
And if anybody has any questions, feel free to add your questions, comments, concerns at the bottom of the screen. And if not today, then throughout the week, Dr. Hala Nelson will be happy to go in and provide some clarifications around your questions. I just want to make note that you're also releasing a new book and a new Substack. Am I right?
Substack, yeah. I'm writing a Substack. You can it's helenelson.substack.com. Very simple. Yeah.
And you're going to be writing about the foundation of data, AI,
Yes. The
and
stuff I've been talking about. Uh-huh.
okay. Well, it's been lovely having you, and thank you very much again for taking the time to give us this wonderful presentation. I think it's a very expansive view, and I think it's a very pure view that also is steeped in experience because you've been a practicing consultant. You've actually implemented these ideas in the wild,
Yes.
and you know that it takes a level of theory, but also a level of pragmatism to get buy-in and execute against these lofty goals.
Yes. Yeah, because it's easy to have all these goals and big goals, but once you sit down and see what's on the ground and how are we going to work with what's on the ground, it's a different story.
All right. Well, thanks again, and be sure to tune in for the last one. That'll be me, so no rush there. I'll see you guys in the next one.
Thank you.